Hi everyone, it's Miss Craig. I hope you're all doing well and had a nice weekend. This is lesson 1 for week 6, Similarity and Right Triangles, our Learn About It video. So the first thing we're going to talk about is the altitudes in a right triangle. So the altitude is a perpendicular line segment from the vertex of the triangle to the opposite side. So in this case, our right triangle is ABC is our right triangle. The altitude is BD. That's the one that makes the right angle on the opposite side. So when you make that altitude, you end up forming 2 more right triangles. So both of the other triangles that are formed when you split it are also right triangles. So the theorem that we are going to be working with is that when you make that altitude, the 2 triangles are similar to each other and to the original. So to practice that, we're going to talk about the 3 triangles that are formed. Just remember, when you are talking about the triangles, you want to make sure that the order is important. If we take our original triangle and we go from U to V to W, that's our original right triangle. That's triangle U, V, W. A little squiggly means similar. And then we put in our altitude. The next right triangle that's formed, and again, order is important, is we would then have U, W, Z. So we could sketch our next one would be U, W, and Z. We have triangle U, W, Z. That's this one in here. Let me redraw that one. That would be this one, U, U, W, Z. And then our final one would be triangle W, V, Z. So that would be our third triangle. Similar to triangle W, V, Z. So again, we want to make sure we go in the same order. So again, we're going to compare our 3 triangles. So our original triangle is G, J, K. So that's our original G, J, K. Triangle G, J, K is similar to our next right triangle would be J, J, M, K. So again, if we're making that right angle in the center, we triangle J, M, K, similar to, and then our final one would be G, M, J. So each time the right angle is the one in the center in this case, so the order matters. So now we're going to talk about something called the geometric mean. So when we're talking about the geometric mean, the x's, in this case, are the means, and the a and the b are called the extremes. And just remember the geometric mean of two positive numbers is the positive square root of their products. So x is the means. It is equal to the square root of the a times b. And we're going to take the positive square root. Because x squared, when we're doing our proportion, is equal to a times b. So again, the mean, which in this case is x, is equal to the square root of a times b. If we're going to find the geometric mean, again, x is equal to the square root of the two extremes. So in this case, x would be equal to the square root of 100. Square root of 100 is a perfect square that is equal to 10. So if we were doing it of 5 and 30, we know that x, which is the mean, is equal to the square root of 5 times 30. So x would be equal to the positive square root of 150, which is approximately 12 and 47 hundredths. So just to review how we're going to use the geometric mean in our triangles, so remember the length of the altitude, the hypotenuse, is the geometric mean of the lengths of the two segments of the hypotenuse. So in this case, the h is our geometric mean, and it's equal to those two pieces of the hypotenuse multiplied together. So in our example, 6 is our geometric mean, and it's equal to the x and the 9 being multiplied together. For example, we want to find that altitude, our right triangle, and then we know that x squared that altitude, which is 6 squared, is equal to those other two pieces multiplied together. So it's equal to 9x. So 36 is equal to 9x. Divide both sides by 9 to solve, and x would be equal to 4. So now if we apply this to a real life problem, they are telling me that the height of the fir tree, so that her line of sight from the top to the bottom makes that 90-degree angle. She's standing 7 8 meters away. What is the height of the tree? So again, that altitude is equal to, when we multiply both pieces of the hypotenuse. So in this case, that would be 1 6/10 times x, because we don't know what that remaining height is. So then we would do the math. And when we do the math, we end up with x is equal to 38 25 thousandths. So we're going to approximate that to 38. So that x is worth 38. So if we want the height of the entire tree, we would have to take the 38 plus the 1 6/10, and we would get 39 6/10 meters. So another real life example, it's the same kind of thing. There's our surveyor. We have our altitude at 28 feet. And then we have our two pieces of the hypotenuse. So we know we would have 28 squared would be equal to 5 5/10 times x. Again, we would do the math and we'd end up with x is equal to 142 and a half. This piece would be 142 and a half. But to get the entire height, we'd have to take 142 and a half, 5 and a half. And if we do that, we get 148 feet tall. So next, you'll go on to the try it section. I'll make another video. You'll do the practice problems, check all your answers. If you're in my name is Thomas's class, you'll do the additional activity. Stay well, and I will talk to you during the try it video.